Good evening, sir.
Good evening. Good evening to all.
Good evening, sir.
Good evening.
How are you, sir?
Good evening, sir.
Good. Thank you.
Sir, recognize my voice?
Akshat,
Yes, sir.
So is he the guy who was threatening the office boy for chai?
for a cup of tea.
I went to the Gautam sir today also for the SKCH circle lecture.
The
And
meeting is being recorded. ध्यान से.
तो फिर सर अपन क्लास में बात करेंगे. Sir, the other people also there in the group meeting.
Huh?
The other are also there.
Yeah. Gauss Law. People are yet joining. Gauss Law Assignment. Bolo.
Question 6, 7, 8.
So question 6, 7, 9, 10.
3.
18.
So 14, 15.
Sir, 13. Sir, 15.
Sir, 2.
So we are on the track to complete the entire assignment
So
today.
you can complete the entire assignment.
4, sir.
First problem छोड़ दिया आप लोगों ने.
फिर वो भी कर लो.
मेरे को डाउट है इसमें.
मैं जब कल बताया था ना ऑनलाइन होगा, मेरे को लगा ही कि आप पूरा असाइनमेंट ही सॉल्व करोगे. कितने क्वेश्चन इसमें.
Seriously, first problem doubt है.
So can you even do the fifth
नहीं
one?
ऐसा नहीं है.
So question number 5.
Okay.
16.
Sir, question 4.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is missing, 12 is missing, 13, 14, 15, 16, 17 is missing. First problem is missing. It's okay. I'm happy with the concession of 3 problems. But
Don't
third
tempt me, sir, to
genuinely-
magically get 3 more doubts.
Sir, 12.
Hey, चुप रहे. 12 is missing. अब 3 problems बाकी बचा वो भी बता दोगे. कुछ भी. No. Second one, have a look at it. Charge Q is placed at the corners of an equilateral prism. Then electric flux through the prism is. Now, see this drawing carefully. This is the equilateral prism. I'll try to change the color of the ink if I've got a red colored marker. I will remove this for better clarity. Observe this prism. Are you able to see this part of the prism?
Yes, sir.
Yes, sir.
Its replica on the other side will be this. This part is what we are supposed to deal with. I have chosen that. And remove this also, that will make my life easier. This charge Q will be shared by one such type of prism in the front and one back, which is drawn. The front one is not drawn. Agreed? So how much charge will go into this complete structure? Q by 2? Q by 2 by epsilon naught is the flux through this complete plot. See, if any face centered you take, even for a cube, if you take a face centered particle, if I take a charge Q here, Q by 2 will come into this cube, Q by 2 will go into that cube. So this is at the face of this particular structure. So Q by 2 this side, Q by 2 that side. Q by 2 will come into this. But what he needs is the flux through this. Right? So 1/6 of this, 1, 2, 3, 4, 5, 6. 1/6 of this will go into this. Q by 12 epsilon naught. Second problem, is it clear to all?
Yes, sir.
Tell me when I can rub the board.
So can we also do this by arranging the prisms in such a way that it forms cuboidal structure?
Actually, yes. But for that, you will have to draw on the board that. Only then we'll be able to explain to the others. So today's class, there are more than one procedures available. Keep your procedures aside. When I'm there in your class, tell me, we'll put it on the board.
Yes, sir.
So I couldn't get him. What did he say actually?
That's why I said we'll do it in the class. Don't. Learn only one procedure. Can I rub the board?
Sir.
So 1
Yes, sir.
minute.
Third question is not a reasonable doubt. Not acceptable. Listen. For this Q, third is not difficult. You have got 4Q here. This corner will be shared by 8 cubes. Now you are asking me total flux passing through this cube. So 4Q divided by 8 by epsilon naught plus if I am right, Q is placed at the center of the cube. So Q by epsilon naught plus 3Q is placed here. 3Q will be shared by the cube above and this cube. So 3Q by 2 by epsilon naught. Right? 2Q is placed here. This corner is shared by 4 cubes. This corner will be shared by 4 cubes. You should be able to visualize this. Right? 1, 2, 3, 4. This cube will come this way. This cube will come out. These both will come out. This corner is shared by 2 cubes here and 2 cubes behind the board. Behind the board wala I will not be able to draw. 2 cubes front of the board, 2 cubes behind the board, this corner. So 2Q by 4. Now add all the 4, you should get the answer.
Yes, sir. You can draw.
Fourth question is undoubtedly a tricky one. Here, they wanted to play with one of the parameters. It's a cube. Now watch out for this. At a distance of x, I'll consider this to be of thickness dx. What will be the dq enclosed inside? Rho into 1 square into dx. Rho into 1 square into dx. Cube of h length a. So this is 1. This is 1. This thickness is dx. 1, 1 in dx. 1 into dx.
Yes.
Agreed? So this will technically be rho dx. This is the charge enclosed inside. Right? Now, if I integrate this, Q will be integral rho dx. तो क्या करूं यार अब? अरे भाई साहब ग्राफ for rho and x is given. Graph for rho and x is given. Integral rho dx, don't you think will be the area under the curve and above the x-axis?
Yes, sir.
A very well played problem. Some graph is given. Now area underneath will be integral of rho dx. Now I need this because I need the charge. How will I get this? Don't write the functions of this and integrate. I said there's the area under the curve, definition of integration. In any paper or assignment, Gargi, you typed something to the co-host. I can read only one part of the message. Co-host is my cell phone. Type it to the host so that I can see that. In any part of the assignment, always remember this mindset. First 6 problems, if they are difficult, the balance problems, even if they are easy, psychologically you will start assuming them to be doubts. Actually, first 6, 7 problems are difficult. balance the problems from 14, 13, 14, 15. They're quite easy. When I solve, you will see. But the problem is in the mind. First 6 problems very difficult. I agree with it. Now, once you have solved first 6, you by default assume baki bhi nahi aaye. So
Yes,
your
so when I opened the assignment, the first page was looking tough and I wasn't able to solve any of those. So I started from behind and ek ke baad ek questions hote gaye. Then even the first one started becoming easy.
So try to develop the habit of looking at every problem rational. One problem may be difficult, one problem may be easy. Look at it rational. Actually from 14, 13, 14, 15, 16 are very easy. 18 again may make sense. It's an old JE and a tough question, 2017 JE question. Can I rub the board?
Yes, sir.
Yes. So wait, so in this you have to find the flux through the whole thing, right?
Divide by epsilon.
Give divided by epsilon naught. Q is
Yes.
known, Q by
I get
epsilon
that, sir, but
known.
the options are not given like that.
Hey, which way?
So I think he means ki like there's no epsilon naught in the option. So because the answer comes out to be 3/4 epsilon naught into
Epsilon
sigma or
naught is given,
whatever,
right?
and then that other quantity it becomes 1 only when you multiply it.
Okay, right. Now, 5th is a very good one. Please observe this. At this height,
wrong for fifth?
Negative and one.
correction I have sent
No,
to
sir.
the answer is B.
Answer
Bombay.
B.
B Bombay.
Yes, sir.
Okay. Now, listen. You have a plus Q charge here. Right? You want to know when this is moved up, what will be the flux through this. Indirectly, you are asking me what is the flux through this upper cone when this is here. Am I right? Identical upper cone of height. Same height. Firstly, when the charge is here, I'll call this flux phi1, I'll call this flux phi2. Flux through this curved surface, this curved surface. Both the curved surfaces put together, phi1 plus phi2 should be equal to Q by epsilon naught. Do you agree with that?
Yes, sir.
Now, you are telling me phi1 is given, right? Found that flux associated with the cone with the curved surface area is 3Q by 5 epsilon naught. Phi1 is 3Q by 5 epsilon naught plus phi2 is Q by epsilon. Phi2 is equal to Q by epsilon naught minus 3Q by 5 epsilon naught. The subtraction will not be difficult. Now, when you move this 2h above, if you are moving this above, you want the flux through this. Directly, you're asking me phi2. If you are moving it above to a height of 2h here, now this will be phi1 and phi2. You are asking me phi2. From here, you move it above phi2. That's what you have calculated.
Yes, sir.
An idea changes your life.
So can you explain again the second part?
When I move this above, phi1 and phi2 interchange, right? When Q is here, the flux through this curved part is phi1. When I move it above by the same height, flux through the upper part will be phi1. Yes or no?
Yes, sir.
You are asking me to calculate phi2, which I have done.
Okay, sir.
So the answer
So-
given is 0.
No, rectify the answer. I have sent the correction.
Yeah.
Answer should be B. B for Bombay. Fifth ka answer is B for Bombay.
Sir, if I want to enclose the charge cube in more than 2 cones, then where should I place the charge cube?
What
Like,
the
is it possible?
क्वेश्चन क्या है? You want to enclose the charge in more than 2 cones.
Yeah, the charge q. Is it possible?
Yeah. Take one cone here, one cone here, one cone here, one cone. Keep charge Q here. All these cones will बहुत सारे cones में share कर सकते हैं. 1, 2, 3, 4, 5, 6, 7, 8. So each of the cone will get Q by 8.
Sir, but this is only 2 dimensions,
sir.
right?
Pardon?
Won't there be more cones?
भाई साहब उसको सिर्फ 2 से ज्यादा चाहिए. मैंने 8 ड्रॉ किया, आपको 9 चाहिए. क्या पूछ रहे हो एक के बाद एक? No. Fifth I have just done. Sixth is a tough one. Here R is a vector. It is given in bold. Here R is the vector. ध्यान से देखिए. First of all, I will take an element here. This is the vector R, right? This will be E naught R. Agreed. This area vector will be ds. This will be P. Right? D phi in this particular case is E naught R. Radius of this angle is taken as theta. So if this is R, radius will be R cos theta. Do you agree with that?
Yes, sir.
Yes.
E naught R ds cos theta. Field area ds cos theta. E naught R cos theta into ds. What have I done? I took the field, I took the area ds into cos theta. Now R cos theta, I put it in one bracket for quite obvious reasons. Right? E capital R ds d phi. Integral of this. E naught R. E naught is a constant, I brought it out. Capital R is a constant, I brought it out. Integral ds should not be difficult for you. 2 pi r h. E naught R into 2 pi r h. This will be the flux through the curved surface A. Problem is not at all. Now the problem is, consider this. This will be E naught R. Agreed? Now,
Yes, sir.
this angle will be 90 minus theta. See, this angle is theta. This angle will be 90 minus theta. Do you agree with that, the small angle? So E naught R ds cos of 90 minus theta will be the flux in this particular case. Agreed? This will be E naught R sin theta into ds. What is R sin theta equal to? Can I call it to be H? Say something.
Sir, can you explain the 90 minus theta?
If this angle is theta, this will be 90 minus theta. Who is this?
Sorry, sir.
If this angle is theta, you are asking me how will this angle be 90 minus theta? Now you take this angle as theta. So this is theta. This will be 90 minus theta. Integral ds. Integral ds will be how much? Pi r square. Pi r square. Flux through the curved surface area, flux through the upper part of the disk. Why did I not calculate the flux through the lower part of the disk?
0.
Perpendicular.
So the area vector is perpendicular.
Exactly.
सर इससे बहुत ज्यादा आसान मेथड है 2 स्टेप में आंसर आ जाता है
बोलो
सर हम लोग को ये दिया हुआ है कि जो फील्ड है वो आर से डायरेक्टली मतलब डायरेक्ट रिलेशन में है ना प्रोपोर्शनल है राइट तो वो हमने जो केसेस पढ़े हैं उसमें सॉलिड स्फीयर में आता है, इनसाइड अ सॉलिड स्फीयर. So we can assume कि there is a solid sphere which contains this whole cylinder centered at the point जहाँ से हम ले रहे हैं theta. So we get.
Wait. You want to draw the solid sphere like this?
Yes, sir.
This is the center.
तो इसमें से what we gather is कि charge density constant हो गई.
क्या
And
constant?
then अंदर charge enclosed निकाल लेंगे.
Last line I didn't understand.
सर हमने जब ये कंक्लूड किया द रिजल्ट वाज जब सॉलिड स्फीयर के अंदर चार्ज डेंसिटी कांस्टेंट है ना, तो इस सिलेंडर के अंदर भी चार्ज डेंसिटी कांस्टेंट हो गई.
Did anybody get this point?
Sir, can you?
Sir, there is no charge to be constant.
No, he's defining charge density constant from this information.
सर चार्ज एंक्लोज है इसीलिए फ्लक्स आ रहा है ना, तो देयर इज अ चार्ज और चार्ज डेंसिटी कांस्टेंट होगी तो ही वो आर के डायरेक्टली प्रोपोर्शनल आएगा.
Up from the field, you are calculating the charge.
From the
No.
field I am saying कि we can assume this is enclosed in a solid sphere of any size larger than the cylinder and उसके अंदर चार्ज डेंसिटी कांस्टेंट होती है, तो इसके अंदर भी चार्ज डेंसिटी कांस्टेंट हो गई. तो चार्ज एंक्लोज्ड आ गया तो फ्लक्स भी आ जाएगा ना.
Sir,
I'm not sure about it.
sir, how can we conclude the charge is inside the cylinder?
Don't worry about it. I'll discuss it with him in the class. If the procedure is impressive, I'll keep the other batches also in.
Okay.
I'll give the copyright act to this guy only.
Sir, that is wrong because proportionality constant is not same.
अरे मिल जाएगा जो इक्वेशन दी हुई है उसमें से. You'll get it on the.
शायद उसने कैलकुलेट किया, पता नहीं. Let's see.
तो मैंने किया है, मैंने इसी से किया था.
Okay. I'll not be judgmental. Don't worry. Let's see the solution. If it works out, only then. But first, take this.
Sir, in the fifth question, why didn't we take flux through the circular plate?
ऐसा क्वेश्चन पढ़ लो एक बार. क्वेश्चन में उसने थ्रू द सर्कुलर प्लेट नहीं पूछा, थ्रू द कर्व्ड सरफेस पूछा.
हाँ तो in the equation where we are writing phi 1 plus phi 2 is equal to q by epsilon naught, shouldn't it include phi 3 and phi 3 as well?
बिल्कुल नहीं. Upper cone and lower cone put together is one closed body.
Yes.
Upper cone and lower cone put together is one. अंदर कितने भी surfaces draw कर लो. I will take a cube like this. I will draw any number of cubes inside. Now I have a cube here. Flux through whole of this is q by epsilon.
Q by epsilon.
Now I draw in another cube like this. क्या फर्क पड़ेगा मुझे? कुछ फर्क नहीं पड़ेगा. Through the outer cube, it is again q by epsilon.
Yes, sir. Got it.
ये disk है नहीं है doesn't.
Sir.
Hello.
Sir. Sir, first I wrote down the field in terms of the vector components. First E naught x I cap.
Can be done. Understood. That can be done. No issue. R you will put it in terms of I cap, J cap, K cap. Am I right?
Yes.
Can
yes.
be. Tell me when I can rub the board.
Done.
Yes, sir.
Seventh problem is slightly dicey. Wish I could draw this properly. a little bit of patience. I did a great job. This is C, this is B, this is A. Right? But don't name this, I don't mind. Now, what are we actually in search of? Technically, the angle subtended by this part, and this part at the center is my requirement. Right? Angle subtended by this part, and this part at the center is my requirement. Agreed? Now,
So all the three angles will be same, right?
they will be same. First of all, I'll call this theta, this will be theta. This will be C. Center is being called as C.
Sir, can you explain the thing again?
Which thing?
Sir, that you told that the angle subtended by is
Don't worry about it, I'll come to it. First listen. First of all, do you know the question?
Yes, sir.
Now listen. Now I'll call this A, B, C, call this D. I want to calculate CB. I want to calculate CB. BC. BC will be 1/3 the length of this median. This is the centroid. Centroid divides the median in the ratio of 2:1. So this will be 1/3. What is the length of this side given to you?
3R.
3R. Can you make a guess what will this angle be?
30 degrees.
So 3R cos 30. 3R cos 30 will be the total length. Uska 1/3 will be BC. Do you all agree with that?
Yes.
Cos 30 is √3/2. This will be R √3/2 is the value of BC. Agreed? Find out cos theta and keep this as information. Cos theta is adjacent side BC by CA. BC is R √3/2 by R. This will be √3/2. So how much is theta equal to?
30.
5/6.
Somebody said 5/6. Let his wish also be full. 30 degrees. Right? Now listen carefully. I wish I used different color schemes. This angle I will call it by a symbol phi. Right? Again, I'll remove this because this angle is phi. This angle is phi. First of all, observe that carefully. Are you people able to see that, or should I pull the camera a bit more closer? And I am keen on calculating phi. That is of my main interest because that is the length inside the triangle. This is the length inside the triangle. This is the length inside the triangle. Do you get that point?
Yes.
Calculation of phi is of big interest for me. Agreed? Say something till here. Is it clear?
Yes, sir.
Yes, sir.
Now, if this angle is 2 theta, will this angle also be 2 theta? Will this also be 2 theta? Because this length subtends an angle of 2 theta, same length. So, 2 theta into 3. This angle is also 2 theta. This angle is also 2 theta. This is 2 theta. What makes you say that? This length and this length will be the same. 2 theta into 3 plus pi into 3 should be equal to 2 pi. Theta, you already know, is 30 degree. 60 into 3 plus 3 pi is equal to 2 pi. Theta, I'll keep it as pi by 6. 2 pi by 6 into 3.
6. 2 pi by 6.
This will become 2, 2, 2. This will become pi. 3 pi is 2 pi minus pi. 5 is equal to pi by 3. Phi angle is pi by 3. Can I find out this length, and this length using sector formula?
Yes.
Sir, pi r pi by 3.
Pi by 3 into r is this length. Do you agree with that?
Yes, sir.
Yes, sir.
This into L into 3. Why L? This is the two-dimensional view. Length of the cylinder I should take on the other side. Right. So what will be the flux? Net total charge. Net total charge. Cancel out this. Net total charge. Sigma pi r L. Pi r L by epsilon naught. This should be my answer. Pi is missing in the answer given for C. Pure plain geometry. All that I had to find out is this length, and this length, which comes inside the triangle. Something that we learned in 9th and 10th. But I can understand your pain in it because you people went through COVID time. That time. Hence, it is a COVID batch.
Sir, does the prism project inside or outside?
What difference does that make? Suppose I say it was inside or outside. This is the cross-sectional view.
It doesn't make any difference. So, how did you assume that the prism intersects the cylinder at these points? Like, it could have been so large that the cylinder fits inside it, touching it at no points, or so small.
Dimensions देख लो 3R दिया हुआ है इसका. Prism का dimension 3R.
Oh,
While R is the radius. They took adequate care in play.
So, what is L? I couldn't figure out from the
L
question.
is the length. This length.
Okay.
Prism length. Cylindrical length.
How it's projection.
Projection. This is the cross-section view. This is the cross-sectional view. Ironically, what is the physics involved in this?
Nothing.
Charge upon epsilon naught.
Sir, Gauss law.
Last step. Everything else is pure mathematics. That was not taught to you people in 11th. This is not taught in 11th. Tell me when I can rub the board.
Done, sir.
Sir, 1 minute. Done.
Eighth question again is playing with plane geometry. This ring is moving ahead, right? This ring is moving ahead. when do you think this chord, this length is maximum inside the sphere? That will be the maximum flux.
Diameter.
When this is maximum, the flux through this will be maximum. That will be maximum when this chord is maximum. That chord will be maximum if that is the diameter. So this will be R by 2, this will be R by 2. Actually, the problem is over from here. Calculating theta is not difficult for you. Sin theta is R by 2 by this is R. This is 1 by 2. Theta is 30 degrees. Agreed?
Yes.
So this total angle will be 60 degrees. So this sector length, how do I get? Sector length 60 degree into R. Now how do I get Q? Lambda into pi by 3 into R. How do I get the flux? Q by epsilon naught. Tell me when I can rub the board.
Answer.
Ninth question. Did I draw well?
Yes, sir.
I shaded one half of this circular part, one half of this vertical circular part. What is this particular area equal to? Area vector. Pi r square by 2 minus j cap. What will this area vector be? Pi r square by 2 minus I. Minus I. Do you all agree with that?
Yes.
Till here, are you sure? Are you
Yes.
able to see the board?
Yes.
Now, what is the field that you have given to me? Field given is E naught I cap plus 2 E naught J cap plus 3 E naught K cap. I'll make my job simple. Field dot area will be the flux. Area, how much do you want me to take? Pi r square by 2 minus I. Pi r square by 2 minus j cap.
2 E naught K cap आएगा.
क्या?
2 E naught K cap आएगा.
तो 3 E naught की जगह 2 E naught.
2 E naught. क्वेश्चन में 2 E naught दिया हुआ है. My bad. But I think that is 3 E naught here. Then answer में थोड़ा दिक्कत आएगी. I took 3 E naught and solved. I got the answer. That should have been a misprint then. Ninth question में what is the answer given? A. You will get A only if you take 3 E naught. Question में you will have to make the change. 1 second, let me do the simplification. Then you will make the change. Now, here life becomes much more simple. 0 K cap. Now dot product pi r square by 2, right, minus E naught. This will be Hey, luckily this value doesn't matter.
sir.
Minus pi r square by 2, 2 E naught. G cap will be 1. This will be the flux. This is the negative flux through these two surfaces. Net flux through whole of this structure should be 0. Why?
Sir, flux through closed surface is 0.
When there is no charge in. Don't forget to say that. There is no charge inside that. Hence. Right? So now this is the flux negative. Equal flux positive is my answer. Equal flux positive is my answer. Cancel these both. Right? In this case, I will get 3 by 2 pi r square E naught. Positive of this value should be my answer, which will be the flux going through that. Whether this is 3 E naught or 2 E naught, it doesn't matter. I might have gone wrong in giving you the value, but luckily the 0 saved me.
Sir,
Bolo.
sir, why aren't we considering the area by k cap? मतलब 3 by 4 pi r square.
ठीक है कहाँ पे क्या कहाँ पर कंसीडर
सर मतलब फील्ड दिया है तो 3 by 4 pi r square k cap भी आना चाहिए ना.
अरे भाई this cross sectional area and this cross sectional area में k cap कहाँ आएगा ये वेक्टर कहाँ से आएगा this area is like this
yes
this area is like this
yes sir.
k cap का area कहाँ पर है this part you have removed there will be only two areas
हाँ sir, got it.
visualize it there will be two areas.
So इसमें they have asked flux coming out of the curved surface, तो flux going into the curved surface का regard नहीं लेंगे क्या कुछ?
Flux coming out of the curved surface will be positive. Flux coming out, E and ds.
No, so we took plane surface के through क्या हो रहा है? Right, जो उसके सिवाय का है that is net of curved surface, but उसमें entering leaving अलग अलग होगा ना?
Yeah.
I don't know. हमने
net total flux through this is 0. Do you agree with that?
Yes sir. हाँ.
So these both have got negative flux.
Yes sir.
The remaining part should have equal positive flux only, then it will be 0. Yes sir.
Yes sir, but उसका in total positive उतना है, it can have some negative and some more positive to cancel it out ना. We don't know कितना enter कर रहा है कितना बाहर जा रहा है. उसका net positive इतना है.
You mean to say among this part, some part may considered to be negative, the other part will be positive and summation will become 0.
So जो हमें इधर आंसर आया that will be a combination of अंदर जा रहा है बाहर आ रहा है ना. Through the curved surface अंदर जा रहा है, through the curved surface बाहर आ रहा है. Curved and plane मिला के जो है उसके अंदर 0 है flux. But curved में अंदर जा रहा है और curved में बाहर जा रहा है का sum is not 0. उसका sum will be जो हमें अभी आंसर आया.
I understood your point. You can eliminate that by drawing the field lines. Take them separately. E naught I cap, 2 E naught J cap, K cap.
Yes sir.
Right. Visualize all three separately.
So they will enter also ना. I cap अगर left to right जा रहा है तो it will enter and then leave ना.
That will become 0 no यार.
So हम सिर्फ net को 0 बोल सकते
curved surface पूछा हुआ है. Through the curved electric flux coming out of the curved surface of the sphere.
So coming out पूछा है.
Everything else is entering in the curved surface. It should also be coming out.
Yes sir, but जो हमने
So
अभी
that will turn
निकाला.
out to be 0.
हाँ, but उसका coming out वाला part should come in the total coming out ना. There is something going in and then उतना going out plus इतना extra going out.
If that is the case, the wording of the question will be clear. If they asked you this way, implies it's quite obvious. You can take it for granted. Or do you have a means in which you can calculate that?
No, I don't. That is why I was confused.
Then why do you waste your time for that? If they want it, they'll
Because
give you.
ये तो गलत आ रहा है ना. This is not fundamentally correct ना. Question के wording के हिसाब से.
Question के wording के हिसाब से, if they want you to do that calculation, they'll give you the information regarding that. They didn't give you any information regarding that. Don't assume things in the question.
Okay, sir.
So in this, how did you decide if it's pi r square minus I cap or I cap?
You are taking the outer surface of whole of the body. Here
Oh.
also you are taking the outer surface. Here also you are taking the outer surface. You cannot take inner surface on one side and outer surface on one side.
Okay.
Tell me when I can rub the board.
Yes, sir.
Yes.
Tenth question. You have a thin wire. Now you don't know this particular flux, this length, right? So the charge density lambda is given. Now, if I can calculate the flux through this circular path, because of the wire, this will be k lambda by, I'll take this to be smaller, right? This will be k lambda by small. Now, this k lambda by smaller with this area will give me 0 flux. So, d phi will be equal to k lambda by r, into 2 pi r dr. Integrate this from 0 to r. Will I get the flux through the circular path? I know the flux total will be equal to lambda r by epsilon naught. This will be the flux through the circular part plus flux through the hemisphere. You want the flux through the hemisphere. You know the total flux. This flux through the circular part, you substitute here, you will get the flux through the hemisphere.
So,
all that
sir,
is
in this question, if we take the mirror image about it, then we get symmetrical.
yes, sir.
Break
That is
half.
the easiest one.
Sir, if we take mirror image about it, तो उसका हो जाएगा कि lambda by r हो जाएगा और by 2 क्योंकि दो parts में.
Mirror image of the hemisphere बोल रहे हो?
सर
Yes,
पूरे
sir.
का ही mirror image लिया.
We complete the sphere.
सर मैंने पूरे का image ले लिया तो एक infinite rod बन गया.
Mirror image of
Sir,
rod.
complete thing.
I think he's talking about completing the sphere.
Complete the sphere. Rod is kept the same way or rod is extended?
Sir, rod also.
Rod you made it from minus to plus infinity?
हाँ sir.
हाँ. Now tell me.
तो सर इसका k lambda by r. मतलब we find the charge and then we divide by 2. Sir.
No. Charge is lambda into 2r. Divided by epsilon naught is the flux through whole of the sphere, right?
Yes, sir.
You want the flux through the hemisphere, it will be 1 by 2.
Yes, sir.
Did you people get what he did?
Yes, sir.
Yes, sir.
So we can all through. But then
can
charge भी by 2 करना पड़ेगा. Lambda by 2 करना पड़ेगा. Because actual existing is only this side. This side is not existing.
So, or we can say that we simply neglect, we just complete the sphere, not extend the rod at all.
That sounds ideal. That sounds ideal. Complete the sphere. Right. Now the flux through this will be lambda into r by epsilon naught. This will be the total flux. But here I have a problem. The problem is this is not symmetrically placed. Flux through the complete sphere q by epsilon naught aega. This is not symmetrically placed. If you recollect, when we constructed a cube, charge at the center, it was symmetrically placed. You said total flux is q by epsilon naught. Flux through each phase is q by 6 epsilon. This is not symmetrical.
सर इंस्टेड ऑफ टेकिंग लैम्डा बाय 2 मैंने ऐसा क्योंकि उसका मिरर इमेज लिया, उसके बाद मैंने बोला कि लैम्डा आर बाय एप्सिलॉन नॉट हो जाएगा, मतलब लैम्डा इनटू 2 आर बाय एप्सिलॉन नॉट
Mirror image of.
सर
Don't
कंप्लीट
tell me मेरा मिरर इमेज लिया कि आपका मिरर इमेज, मैं बहुत बार पूछ चुका हूँ. मिरर इमेज ऑफ.
सर इफ यू टेक द मिरर इमेज ऑफ कंप्लीट थिंग, मतलब रॉड को भी
This is
लिया.
what you are doing. Am I right?
यस सर. सर इसके बाद लैम्डा इनटू 2 आर बाय एप्सिलॉन नॉट हुआ, उसके बाद एक हेमिस्फीयर के थ्रू उसका हाफ हो जाएगा, और अभी इसमें लेफ्ट साइड के रॉड का और राइट साइड के रॉड का है, तो फिर एक साइड के फिर से सिमेट्री का, तो एक साइड के रॉड के लिए हाफ है.
You're getting the answer from that.
यस सर.
Yes, sir. So actually, like you told me my mistake, but even if I actually commit that mistake, I'm ending up getting the same answer.
See, no, this is dicey. I
Love.
don't mind committing a mistake. I'll get the correct answer. I have no guarantee for that. But by symmetry, you're getting it. In this problem, though this appears to be short, anytime I would be more than happy to tell you a shortcut, but I would prefer this. This appears dicey. Because it is a sphere, it's working out for me with this 1 by 2. Because overall, I changed the problem. I have extended this rod to minus to plus infinity, which won't be my cup of tea. I will not be happy doing it. Getting the answer is not the only priority.
So we should use the integration, right?
Break.
Yes, sir.
Don't. I won't suggest. Okay.
So, but usually you take ds as like a point and then you integrate it, right? ds is the area of a point usually.
Do you know surface integrals? कर पाओगे वो integration? एक एक बंदा आइडियाज जबरदस्त देते जा रहा हूँ यार, सिंप्लीफिकेशन करके तो देखो, नहीं होगा.
Okay, okay.
आप लोग आइडिया ऐसा देख लो जैसे कि मेरे लिए होमवर्क है, आप करो बोर्ड पर. नहीं करूंगा. 13. बहुत ही आसान क्वेश्चन है 13. They made it look complicated. यहाँ पर कितना फील्ड दे रहा है? फील्ड इज 200 I cap दिया हुआ है. What will this area be? 100 I cap. अरे भाई साहब, यहाँ पर फील्ड इज गिवन एज 200 minus I cap, right? Area is 100 minus I cap लिख लो अगर जरूरत है तो. फ्लक्स नेट, यहाँ पर फील्ड इज 200 एरिया वेक्टर्स आर परपेंडिकुलर, flux will be 0. Flux total will turn out to be 2 into 10 to the power 4 plus 2 into 10 to the power 4. This flux and this flux, will you add them up? E dot A is positive, E dot A is positive. Yes or no? Equate it to Q enclosed by epsilon naught. Q enclosed. This is 4 into 10 raised to 4 into epsilon naught is 8.85 into 10 raised to minus 12 in SI units. See if you are getting the answer. Today morning in the 3 years batch, one of the child was showing me the simplification, telling me answer nahi aa raha. I multiplied this right now in the evening and I saw I'm getting the answer. Fair tall boy. who sits to my right on the second bench 3 years back. Is he there? He was showing.
Pranav.
Panav.
Arnav, is it?
Panav. Panav.
Pranav.
Check the physical descriptions.
आंसर आ रहा है कि नहीं?
Yes.
Good. Can I have the book? ये बड़ा आसान क्वेश्चन है. Yes or no? It's a psychological game. First few problems become difficult. बाकी का problems by default we assume is difficult. That way today when I saw the 3 years kids attempting this, that was impressive. They were very rational with the problems. First 8-9 problems they took time, after which they were moving fast. So they were actually very practical with those questions. Fourteen. All the more is very easy. Protein. Name that. O, A, B, C, D, E, F, G, H क्यों नहीं आ रहा है क्यूब में? H तक आना चाहिए ना यार.
So you took an O also.
आपने 2 बार D ले लिया. हाँ नहीं O लिया.
आपने 2 बार D.
E is given as 2 बार नहीं. This is O. 4i cap minus 3y square plus 2 j cap. अब इसमें मुझे हर बार डायरेक्शन नहीं देखना है, मैथमेटिकली सॉल्व कर देना. See, this is dot product in I cap, J cap, K cap will be very easy for you people. Now, let me see flux through EDCB. I'll write the area vector. Dot product you people say. Area vector for, first of all, DEBC. DEBC. Right? I cap, right? What is the area of this cube? Cube का side कितना दिया हुआ? 1. Right? This will be I cap. 1 I cap. Area of, I'll take one more. GFED. GFED. This will be J cap. Area of GFAO. GFAO. This will be minus I cap. Area of, why am I writing all? Now you know how to do it. Can you find E dot A?
Yes,
I
sir.
got name.
Yes, sir.
Right? E dot A यहाँ पे.
Yes, sir.
E dot A यहाँ पे. Similarly for the other faces, E dot A आएगा कि नहीं? Add up all. Some will be negative, some will be positive. Add up all. Will I get the total flux?
Yes, sir.
Now you know how to do it. Putting this quite easy. Dot product of two vectors, as simple as it. That two area is given as 1. 1 I cap. For this 1 J cap. 1 minus I cap. 1 minus J cap. For this FEBA, it will be K cap. 1 K cap. GDCO, 1 minus K cap. Dot product with A. Net total flux through each of the phase. Sum of all of them. Job done.
So the y square plus 2 will not affect anything. It's not constant now.
It's a cube, right? Where y is equal to 1.
It's not everywhere. Y ranges from 0 to 1.
Which phase are you talking?
in suppose 1 second.
Sir.
Make your life easy. This is X, this is Y, this is Z. Which phase do you want me to? I'll calculate for one phase where you think Y is varying. Give me one phase.
So DEBC.
D, E.
Okay, but BC, but then in the dot product it doesn't show. Yeah, okay. Understood.
Right? Can I rub the board?
Sir.
$15. Reasonably easy. E into 4 pi x square dx. Spherical surface. This will be integral of rho naught r square 4 pi r square dr. This will go from 0 to x by epsilon. E into 4 pi x square. R is the variable. You are going up to x. Total charge up to 0 to x you are calculating by epsilon naught. Charge enclosed inside. You will get E directly proportional to x cube. Calculation just for the sake of calculation.
So here you use the knowledge that um the field at a particular distance from the center is constant, right? And then you took it out of the integral.
Naturally, yeah.
Yeah. Okay.
Now, 16th question, they played a very cheap trick. What is the radius of the sphere that you get? Radius of the sphere, they gave x square plus y square plus z square equal to 25, so radius is 5. And the point that they have given is root over of 1 square plus 1 square plus 2 square. This is turning out to be root 6. This will be less than 5. So the point is inside the spherical charge distribution. Point is inside the spherical charge distribution. And the spherical charge distribution is uniform. And the spherical charge distribution is
Uniform.
if there is a spherical charge distribution which is uniform, field everywhere inside will be 0. Yes or no?
Yes, sir.
Yes, sir.
$18 is a node J question. Now, first of all, 18 is important. First of all, get this information. Volume will be pi r square L. volume per unit length will be pi r square. Right? Now, how do I put lambda? Lambda is volume of the cylinder per unit length you have calculated. Right? Charge per unit volume is rho. Charge per unit volume is rho. This is volume per unit length. Observe this carefully. Lambda is charge per unit length. Charge per unit length is required. So I multiply numerator and denominator by volume. Charge per unit volume is density. Volume per unit length is pi r square. This is lambda. Why do you need this lambda? Yeah?
So now we'll do it. 2k lambda by r.
Now you know field is field due to the total. Somebody is called. Are you able to hear me?
Yes.
Yeah. E total minus field due to the cutout part sphere. E total 2k lambda by r. No balance of charge. आएगा कि नहीं?
Yes, sir.
Due to the sphere outside, you know k cube by r square, rather 2r whole square. I will not read this part. See, this is so very silly, but it is difficult to strike at that instant. This was 2017 JEE question. Quite a few students found a trouble with this. I am actually amused that this has to be taught. This actually dimensions se ho jata. Get this relation by dimensions also. This is charge density, charge per unit volume into area. I'll get the charge per unit length. But I am surprised I had to put it this way for students to understand that.
So there's a similar question like this in the booklet, right? With the
Yes.
infinite sheet and
Even
a
in the booklet, I have this problem telling the students. Now, once I tell this, they are able to. There it is sigma and lambda. Here it is relation between rho and lambda. There it is sigma and lambda.
सर इलेक्ट्रो में भी ऐसा एक क्वेश्चन है.
इलेक्ट्रो का ही बात हो रही है. आप 3 years के स्टूडेंट हो.
So 14th question डॉट प्रोडक्ट के बिना भी कर सकते हैं.
14th question. हाँ कर सकते हैं. Yes, 14th is easy. Either way you can. This week we have one more lecture, right?
Sir.
3 years back we thought we will do something different in that lecture. What was it? I forgot it.
Units and dimensions of booklet, and next week you will do E and units and dimensions and errors and measurements.
So you are going to bring vernier caliper
and screw gauge.
So you are supposed to send one tougher assignment for electrostatics, I guess.
So a tougher assignment of Gauss Law.
I will keep that pending. Let your major test be over. No, I'll send it. I'll send it tomorrow.
Okay.
So could you send the recording of this lecture?
Yeah, I'll send it.
So thank you, sir.
Sir. Sir.
Hello.
Sir, I have a question. Sir, can we generalize that dE by dx can be written as the density function? Because in the question you gave in the class also that rho is equal to AR cube. उसमें भी 2 बार differentiate करने के बाद epsilon naught multiply करने से
I'm not getting that point. Meet me after day after tomorrow's class. We'll discuss.
Okay. So how did you get field due to a cylinder's 2k lambda by r?
Cylinder nahi. I converted that into lambda. So then I will write 2k lambda. Cylinder ka Infinite long cylinder will appear to be concentrated along the axis. Infinite long cylinder.
Okay.
All of that will appear to be along the axis if I consider a Gaussian surface like this. So that cylinder's charge I converted into lambda. Lambda is what? Charge per unit length. Then we use 2k lambda. Chalo, see you people in the next class.
Bye, sir. Thank you.
Okay, bye.
Bye,
So wait a
sir.
minute,
Thank you,
please.
sir.